Hey everybody, Mr. Piercy here, and what we're going to be looking at right now is an investigation that demonstrates where the formula for midpoint came from. So before you get started, you obviously need the handout of some kind so that you can kind of follow along. You'll need a straight edge, a pencil, and preferably some patty paper if you have it, because it's pretty transparent, and we're going to be using this to do some things in our investigation. So what we've seen previously in the class is we've talked about midpoint, and it's fairly self-explanatory as far as the name is concerned. It is the middle of 2 points. And what we've done with it in the past is we've seen it on a number line, meaning it's basically just kind of one-dimensional. And now we're going to extend that thinking a little bit so that way we can see it's more of a two-dimensional idea where we can see it on something like this, a coordinate grid that is two-dimensional. So we'll just go ahead and follow along here with it. You can pause the video as you need to do your own things when you're watching it. But let's go ahead and plot our points here, -7 and -6. So -7, 1, 2, 3, 4, 5, 6. And that is going to be point P, and then we have point Q at 5 and 8. And there's point Q. So we're taking my straight edge here, we're going to do like so. So if we want to, we can say -7 and -6 here, and here we can say 5, 8. Not necessary to label it there, but I'm going to go ahead and do it. So we've drawn segment PQ, we're good there. Using a straight edge, draw a dotted vertical line passing through point P and another through point Q. Okay, now this is where the patty paper is going to come into play. What I've already done is I've already kind of copied my X and Y axis down here, and what I'm going to do is anything that I have on my graph, I'm going to copy onto my patty paper. And most of what I'm going to get and do is actually going to be on the patty paper itself. So I'm going to copy segment PQ there. And what it's asking me to do is, it says here, draw kind of a dotted vertical line through points P and Q. So we're going to do like that and make sure we can see. So where's P? We got this guy going kind of this way. So I will copy those obviously here. So we'll make our dotted vertical lines. Okay, so now what it tells us to do, it says fold and crease the patty paper so that the vertical lines are aligned with each other. So that's where the patty paper is really beneficial. You can kind of see even on the camera the dotted lines and how we're going to kind of line them up. And that looks pretty okay to me here. Okay, and so then now you can kind of see the crease made on the wax paper for that. That's kind of why we're using this stuff also, because when we crease it we can kind of see where things are going to be. So what we want to do is, it says mark the segment at the intersection of the vertical crease. So you kind of see here where we have it. We want to kind of mark that here, but we also want to translate, or not translate, but transfer that mark onto our graph paper, and we can see that that looks like that mark is right here where -1 and +1 would be. So I'm going to go ahead and make that mark right there. All right. So in terms of the distance between the vertical lines, what does that represent? Well, the distance between the vertical lines, let's see. If I count the distance from the vertical lines, let's just go along the x-axis here. We're 1, 2, 3, 4, 5, 6, and so there's 6, 7, 8, 9, 10, 11, 12. Well, the distance between the vertical lines is 12 spaces long, and that is in the middle of it. So that's kind of where we're heading with our midpoint. Okay, so using a straight edge, draw a dotted horizontal line through P and Q. Okay, so let's do that now. Dotted horizontal line through P and Q. And I do want that on my patty paper also. There's one. And there's the other one. And also I'm going to fold this one like I did the horizontal lines, or vertical lines I should say. So line up the lines, the horizontal dotted lines, and you can fold it and you can see the crease of the horizontal line and the crease of the vertical line are intersecting at the same place. So that is a very strong indicator again that we're kind of headed towards the midpoint. So mark the segment PQ at the intersection of those horizontal creases. And here in parentheses it says if you're careful, you notice they're in the same spot. So in terms of the distance between the horizontal lines, what does the horizontal crease in the paper represent? Well, it represents the midpoint of the vertical distance between point P and point Q. So mark that spot and label it point M. So we're going to call that M, obviously for midpoint. Now we want to use a capital M instead of a lowercase m because lowercase m is reserved for slope already. So what are the coordinates? Well, the coordinates there are -1 and +1. So fold and crease the paper so that P and Q are perfectly aligned on top of each other. So remember, here's P down here and here's Q. So now I'm going to take my patty paper and fold it so those lay on top of each other, kind of like that. And I'm going to crease it there. And when I open it up, I can see that when I folded the line on itself, it went through point M. It went through the midpoint of the vertical and the horizontal folds. So what does that lead you to believe about point M? It means that it is the midpoint it's the midpoint of segment PQ. So find the average of the x coordinates. Well, the average of the x coordinates in this case was so I'll say average x. So the average of the x coordinates was -7 plus 5, and since I'm adding two numbers, I divide by 2. Well, -7 plus 5 is -2, and -2 divided by +2 gives me -1. Find the average of the y coordinates. So the average of the y coordinates, do the same thing now. So I'm going to say -6 plus 8 over 2, because I'm taking the average of two numbers. Well, -6 plus 8 is +2, and 2 over 2 is a 1. Well, those numbers just happen to coincide with the coordinate that we found for our midpoint when we folded the patty paper. So finally, kind of at the top here, write a conjecture about how the midpoint of any line segment contains its endpoints. Oh, I'm sorry, I read that wrong. Write a conjecture about how to find the midpoint of any line segment given the coordinates of its endpoints. Well, the conjecture would be to find the midpoint, and I'm going to abbreviate here to find midpoint. Take the average of the x and y coordinates of endpoints. Where I don't I just got a pop-up saying that my computer is going to restart. No, don't restart. And it won't let me hide it. Oh no. Okay, well, hopefully this we'll be able to finish this little video here. So write the formula. Sorry about the distraction there, but I just got a pop-up saying that my computer is going to restart. So we're going to say m for midpoint, and since I'm finding two coordinates, I'm going to say the average of the two x values of my endpoints and the average of the two y values of my midpoint. And that, ladies and gentlemen, is the midpoint formula. And I'll come back with another video here in a little bit to show how we use it, because not only could we use it to find the midpoint, but we could also use it to find endpoints. So there's the investigation that shows where midpoint came from. And as always, guys, if you have any questions about anything that you saw, make sure you let me know in your emails or in the comment section of your classroom.